Hello everybody! As developers, we're always trying to build something. That might be a website, or a tool, or an application, or a NuGet package. This is Stef from Samayas, and welcome to my channel. So which kind of developer are you? Do you first develop your whole product and then start looking to automate the build and the release process? Do you start somewhere in the middle? Or do you start planning and implementing it from the start? Personally, I start quite fast by automating the whole thing, at least the build process. I might sometimes take more time, but that depends on whether it's something new or something I know. In the corporate world, of course, you can't just wait till the end. You need to start planning that quite early on. In general, those build and release pipelines might not even be in your control. Sometimes you have full control about that and you can do whatever you want to implement it. But in general, an architectural team will have decided on the standards and you need to stick to it. If needed, you might have some slight variations, but if it can be streamlined with dozens of others and similar and even important projects, it's better of course. So what kind of build pipelines are there? Well, first you have the build-only pipeline, just for compiling the code or packaging, whatever. Next, we have a build and test pipeline, often called CI. It's to compile the code and run the unit tests, to have some linting, to have some static analysis, some security checks. The goal here is to catch the issues even before merging the code. Next we have the release pipelines, CD. Handle the versioning, the packaging and publishing artifacts or generate installers. Next we have deployment pipelines. Take care of deployment of artifacts to the designated environments. And then finally we have the infrastructure pipelines. Build and apply infrastructure using Terraform, PowerShell or some other automation tool. So for .NET, setting up a build pipeline is quite easy, right? Well, first, you just need to call a .NET build, right? But then, if you include some NuGet packages, you also need to do a .NET restore. And of course, if you're serious about your project, you absolutely need to have unit tests. If you're having a website, you might also need to use NPM and gulp. And then, you might need to publish some test results. And then finally, you might need to integrate static analysis, aka SonarQube or other tools. And then after build pipeline, you need to create a release pipeline to deploy your package to NuGet or your website or your executable, etc. So let's dig in. So I've created a very simple library package, top-notch. In my library, I have a helper class. The helper class has two stupid methods, which just does some code to do something, my first method and my second method. Next, I have my test project, and my test project contains one unit test, which only calls my first method. If I go to the library itself, it has the basic .NET 9 component, it has all the components necessary to create a NuGet package, and it has two NuGet references. The first, system threading, is a Microsoft reference. The second, Samayas Common, is a known library hosted on an internal NuGet server. Next, if we look at the test project, I have the basic plumbing and I have a number of packages to run as tests. And I do include coverlet msbuild, which is a specific library to create Cobertura output to see what is covered in unit tests. If I build my library, as you can see, it generates a NuGet packet. Now if I run the unit tests, I have one simple unit test, which is successful. If I run my code coverage, well, as you can see, there's 7 lines not covered and there's 4 lines covered, which is what is wanted. And if I go into detail, you can see which is covered and you can see which is not covered. And by including Cobertura coverlet, that output will also be later shown to the build. And then my project contains 2 extra files. My first is my own NuGet configuration, which has one, the official NuGet server, and which has 2, my internal NuGet server. And a second file is specific code coverage files, which specifies which libraries to include for code coverage and what eventually to exclude. And Visual Studio is configured to auto-detect that file of my project. And that file is located in the root folder of my solution. Now if I have a look at my very elaborate web project, I have one home controller, I have one model, I have a standard template, my web project references system threading and Samayas Common, which is an internal library. It references standard .NET 9, which is default plumbing. And then I have a test project. It has one test class with 2 test methods in there, which does basic testing on my error view model. My test project has the basic plumbing. It references coverlet.msbuild to have coverage results, and it references the .NET project. If I run my unit tests, I have 2 simple unit tests. If I run my code analysis on there, well, it's not great. I have not covered controllers, however, I have covered the model. And of course, that's the goal. Now I have two extra files. The first is my NuGet config file, which contains the official NuGet server and my internal NuGet server. And the second is my code coverage file, which specifies which DLL to cover and what to exclude. And especially for CHHTML, all generated code behind CHHTML is excluded. Now let's have a look at our Azure DevOps. First, I have all my code already checked in. I have my library project and I have my test project. Now let's create a pipeline, and let's start by creating a new pipeline. I'm going to use the classic editor. It shows the correct project, it shows the correct repo. For simplicity, I only have a main branch, and I'm going to create an empty job. On the pipeline itself, I need to give it a name, and I'm going to call it demos, which is the project name, then library build, then CI. Then I need to choose a pool on where this will be running. The default has no agents, and I've created a Visible Studio pool, which will run this. And my pipeline is ready. So the next step in the pipeline is to choose where my sources will be coming from. And here you have a multitude of possibilities where your source code can come from. It can either come from the new modern Azure Git, it can come from the old TFS server, it can come from the enterprise GitHub, it can come from Subversion, or from another Git, In my case, it's the Azure Git, the project is correct, the repo is correct, and it's located in my main library. The next flag, clean, allows you to re-clean the source directories every time you rerun. This takes more time, but in the past, by not doing it, I had some issues. So I prefer to always clean everything out. And then you can choose between just cleaning out the sources and the output, cleaning out only the source directories, or cleaning everything out. And the next flag allows you to tag your source code which has just been built, and that depends on the type of build you're running. If you're just having a test build, or if it's your CI build, or if it's your build that will be used for your production output, depending on that, you prefer to not put a tag, to only put a tag on success, or to always put a tag on the source code. And afterwards, if you go look back at the source code, there's an easy way to link back your source code specific check-in with the build. And so if you have later than issues that your build 1.2.75 has issues, by having this tag, you quite easily can find back where the issues in what code it was. And once you put the always, well, you can choose what version or what tag you put on there. That's free format. And finally, the tag format will depend greatly on what kind of versioning system you're using. If you have a major, minor, plus something, which auto increments or not. If you have a random something, well, depending on that makes sense. Personally, I've implemented an Azure DevOps extension to update the build version every time, and I've made a previous video about that. But here, I'll just leave it to never. Next, the report build status will link back to your source control and will show a badge whether or not this build has succeeded. You only need to check out submodules if inside this Git repo you have included other sub-Git repos which also need to be taken. And that depends on your approach. Sometimes you have a shared sub-Git repo to share something like source files, web files, shared layout, etc. And if you use that, then you need to check the checkout submodules. Next we have the flag checkout from LFS. LFS stands for large file storage. Now should your Git repo use LFS, then the Azure DevOps will only download the pointer to those files and not the actual large files. So if you still need those large files for your build to complete, then you need to check the LFS flag. And then the flag, don't sync local sources, is exactly what it implies. Personally, I've chosen to clean and to re-get everything, but there might be scenarios where you need to rebuild and you tweaked something on a build machine. And by flagging in your current build the don't sync local sources and having changed that sources on that machine, well, you might have fixed it like that. But that's a very specific scenario, which in general you don't use. And then next, Git has a notion of tags. And by default, Azure DevOps doesn't sync those tags. So if you want to have all those tags coming with, you have to select the tag flag. Not having selected that saves you on time and bandwidth, but that again depends on the complex scenario of your Git repo. And finally, the swallow fetch, should you have a Git like Microsoft where you have hundreds and hundreds of check-in and previous versions, by flagging the swallow fetch, you will only get the latest versions or the versions you need on which you're building, and the size needed to download that Git repo and the bandwidth is limited. But that again depends on what kind of Git repo you have and how slow or how fast it is. And so after having set up where our sources are coming from, next we go to the agent. In here, if we want to, we can add one or more agents. Say that in your project you have different subparts that you want to build separately and clearly separate. Let's say that we here build library and just we enter build library, but say there's a separate part which would be related to SQL. We could add a second agent, or we could say agent SQL. And that way we have two or more clear sub blocks that can fail or that can succeed. And so then if either part fails or succeed, we already clearly can distinguish which agent succeeds or fails. Also, depending on the specifics, the first agent can then run on a specific pool, and the second agent could be running on another machine on another pool. And then next, before I'm going to start adding things here under the specific agent, we have variables. First of all, if we have some issues, we can change our system debug from false to true, and then most specific tasks will output much more information, which might allow you to find specific issues with your subtask of your pipeline. Something that I always in general add, I add the build configuration, and in general I build in release, but for whatever reason, if it's a variable and you need to build something in debug, you can. Also, in general, I build on any CPU, but if you need to fine-tune it, you can just specify it here and then later use it as a variable in a task. In general, I also include something as versioning you want. Other triggers. Here you can decide, for instance, to have a nightly build and every night at a specific time to have run this pipeline. That can be daily, that can be weekly, that can include a specific branch or not, that can exclude branches. Extra triggers that if this build pipeline is succeeded, that it triggers a second build pipeline. And so you can create a cascade of builds. And then depending on the type of build, if it's a manual build, if it's something you want to have continuously running, or if it's something which is running on a merge request, you can enable continuous integration. And then here as well, again, specify if I check something in on my main branch, this build is running, or if I check something in on a development branch, this is running, etc. And you can choose either include or exclude. And the second flag, batch changes while the build is running. If you have a very active repo and or your build takes 1, 2, 3 hours depending on the length of your build, instead of having a re-trigger for every individual check-in, if this is flagged, the next 5 check-ins might be regrouped and might be used for the next build. Again, that depends on your scenario. Or save it and immediately test the build. And then the next block is the options. Well, first of all, the build description, as it says, is just a description specifically of this build. However, the build format number is much more interesting. Here you can use a number of variables, and I always try to be very specific. I first use my build definition name, which will be demos library CI. Then I include a date, then I include a revision, and then I reuse my product prefix version and my product build version number, so that when the build is run, I see specifically at what date it is run and what version that might be. Depending on other mechanism that you use, your version number might be automatically updated on every successful run or might stay the same even though the date is different. That's again up to you. Configure this build to be automatically enabled as by default, and the moment something is queued, a build automatically start, or to queue the build but not start it, and that means you need to manually start it or to completely temporarily disable it for whatever reason. Also, depending on this build, you can have automatically work items created upon failure, and you can filter in on all branches or exclude a number of branches. And that can be automatically a bug, a feature, etc. Which is quite interesting is this URL, and then something which is quite interesting, those 3 URLs will give you a status badge, which you can use on another site. And then based on those previous links, I've created an internal website where I can monitor the status of my build projects and as well of my release projects. So based on those previous URLs, as well for build as for release, you can have an overview page somewhere which retrieves that information and shows it on a dashboard. Build can be restricted to this specific project or the entire collection. A build timeout can be specified, and if a build goes over a number of times, the build will be cancelled. And a build job might be cancelled as well if it isn't picked up within the next 5 minutes. And then if you really have something specific and you have like dozens of different build agents, even though you already specified them initially, you might still add some specific requirements. I need SQL, I need JavaScript, I need Python, etc. But in general, it's a good idea that all your build agents specified in your pool have all what is required. So now that we're finished with the plumbing, I'm gonna first add .NET Core and a .NET build. Easy, right? Well, I want to build all CS projects in every directory. And as parameters, I want to specify the configuration, and I already defined my build configuration in my variables, build configuration, and -v equals normal sets the verbose logging to normal. So let's give this a shot. And so as you can see, .NET was smart enough to find out the local nugget.config and to retrieve all the assets necessary to have this build. And so now I've added a .NET restore. I've selected all projects because each project can have NuGet packages that need to be restored. And here I can select a number of feeds which are known. For instance, my local artifact, or I can select a feed from my nugget.config. And finally, I can choose to disable the local cache or not, or I could specify a directory where I want my local NuGet packages to be stored. So let's restart and let's rebuild. And as you can see, first a NuGet restore, then a NuGet build, and we are one step further. What more do we need? Now currently my pipeline is still in manual, but let's say one of the developers did a quick check-in and made a typo. Well, a quick build shows that it's failing. And if we have a quick look at the overview screen, we can see that at some line 20, we are missing a semicolon. So that's the first effective help of the build. If this is a normal build after a check-in, at least you'll see it. If this is a CI build that's configured to run before the merge, you'll see it as well. So after recorrecting the error and rebuilding, again, it's working. As you can see now as well, when updating the option settings, I first have my demos, which is my main project. Then I have my project build name. Then I have the date on which this is run. Then I have the number of fixes. Then I have my predefined version. And then I have the tag which I'm using on check-in. So let's edit the pipeline again. And now let's add .NET Test, since any project which you are seriously considering should have some unit tests. So first I'm choosing .NET Test, and this time, instead of taking all CSproj, I only take a CSproj in a subdirectory test, and I only include my configuration release. And let's give this a shot. And then as you can see, the build is complete and our test is run. And in details, we have one test which is successful. However, if we're on this screen, we don't see anything about test, nothing. We just see that our build is succeeded. So let's correct this. Now I've slightly modified the arguments of my .NET test. The first argument is still configuration, where I specify build or release. The second argument, collect code coverage, enables a test platform to data collect a named code coverage and to include all the artifacts in the result directory. The third parameter, logger TRX, emits test result using Visual Studio TRX logger format. The results directory specifies where those results should be saved. And I pass a variable test result directory, which is specified under variables. And now test result directory points to agent build directory, test result directory. Next, for speed, I specify no build, because in my previous line, I just builded it. vNormal, again, specifies normal logging. And then I specify a setting where in my build source directory, I specify my code coverage run settings, which is also used by Visual Studio and is auto-detected in Visual Studio. And then next, I specify a number of parameters specifically for the coverlet MS-build package I've included in the test project. And the first, coverlet coverage, enables it. The second, coverlet output, specifies the test result directory, which is the variable specified, and the subdirectory coverage. And the last specifies that the coverlet output format should be Cobertura. So let's rerun and look at the results. And then after the build is succeeded, the output of .NET tests has changed a little bit. First of all, you see there's a covered module loaded. You see the test is still successful. You also see there's a covered Cobertura XML file generated. And you can also see the code coverage in total. So that's a start. But for now, we still don't see anything of test. So let's modify that. So now we need to add a task, publish test result. And in publish test result, we specify the test result format to VSTest. We specify the TRX file to test result directory, which has been defined in the variables. And we specify the search folder as test result directory. And we merge potential results. And now let's rerun the tests. And so if we now look at our published test result, one test result is published. And our overview screen is quite different. We have a test block and we have test and coverage 100% passed. So if we now go to tests, this project contains one test, and so we have 100% pass. And so whenever somebody changes something and a test fails, you'll immediately see it here. And so I've updated my test to have a failed test to include, and our build has failed. However, if you look closely, we don't have tests anymore, and not here as well. Why? Well, because our unit test failed. And since our .NET test failed, didn't go to the publish tab. And so in order to fix that, we're going to change .NET test, and we're going to continue on error. And then in the TRX, we're going to flag fail if that test result failures. This means that the .NET test, even when it fails, will continue, and the publish test result will stop the build. So let's check it out. And so after this little tweak, well, my build still failed, and now I have 0 tests passed, and I have still my test result which are published. And I can clearly see what has failed. So that's progress. Now let's fix my original test again. And so after a correction, it's building again. Now the next thing that is missing is our coverage output. So let's fix that. So first we need to add a report generator, and then next we need to publish that report. And the report generator is using my coverage Cobertura XML file. My target directory is located in test result directory coverage report. I'm using the HTML Azure Pipelines Cobertura, and it's using a source directory. And then my publish coverage results needs the path to the XML file and needs a source file, and so I'm set. But since my .NET test might fail, my gatekeeper now is my publish test result, which means that needs to come behind the report generator and the code coverage results. So let's give it a shot again. And so as you can see now, next to my tests and coverage, I have a code coverage tab, and that shows for my library helper that I only have a 33% coverage. And so with some extra lines and tweaks, we have a much more detailed build output. And now the next step, let's include SonarQube for some static analysis. Of course, for that, you either need to have your local SonarQube server, or you can connect to the cloud using SonarCloud. And so the first thing we need to do is we need to prepare the analysis config, and we need to put that first before .NET. And so my server, that was already set up, so I just needed to select the SonarQube internal. Of course, by doing new, you can enter the URL, your token, a name, and you're done as well. And so in my environment, I choose a standalone Sonar scanner, which is installed on my build machine. I currently use version 6.2, and I manually configure my project key, my project name, and additional settings. And so that's the initial step. And then at the end, you need to run SonarQube analysis, and that needs to come at the end. And here I just choose Java Home, and once the analysis is run, afterwards, you need to publish it. And for that, I add the publish gate result. And here again, I don't need to do more. This way, it'll be published. So let's give that a shot. And so now my build is succeeded, and I have an extra tab extension. And here I can see that my quality analysis has been built to SonarQube. And if I now open that result, well, depending on your project, here you have a full integrated overview of your SonarQube project. Now if we come back to this, the only location where we really specified keys which were specific to this library and not to the web or any other project is in SonarQube. So I'll replace the project name by a variable. And so now I've created a block which I can reuse in other parts. And so now I've selected all the individual tasks, and I'm going to create a task group of that. And so I'm going to call this build with test and sonar. It's a build category, and these are the variables it identified as being passed. And we still need to tweak them a little bit. Instead of immediately putting in release, we're going to put in the variable again. And so our default values again point to variables created in this pipeline. So let's create a task group. And so when I am now inside this build, it points to a task group. If I want to modify, I right click and I can still do manage task group. If I manage task group, I end up with a task group which I can individually manage, and this task group can be secured so that only an administrative group can manage this, and an individual user might still have rights to the pipeline to use a task group but not modify the task group. Also, you see we have version 1.x, and we can define new versions we can upgrade, and we can have different versions of our task group. So let's rerun the task group. And even though you've used a task group, when you go in detail, each of the individual lines of a task group is still shown and you still have a result of what happened. And you can still go and look into details for each step, what exactly is happening, what might be wrong, etc. And now every time you add something more, of course, your pipeline build takes more time. It is the combination of the size of your project and your unit tests and everything you do around it. So now I've created a new pipeline, demo web build, where my repo is pointing to my web build. My build agent is empty, and the only thing I need to do, I need to go to build, and under add tasks, I have my task group built with test and sonar. Of course, if you make dozens of those different task groups, you might start by company name, like Samayas something, and here everything is already pre-filled in. My build configuration is a variable, my project prefix version number and build version number is a variable, my sonar key is a variable, my sonar project is a variable, and I've predefined those here. And the only thing I need to do now is start a build. And so as you can see, the second build for my web project went without a problem. And this time we have 2 tests and a code coverage which is worse. So now let's return to our library build. We have our common shared task group, which does the basic plumbing, .NET Restore, .NET Build, .NET Test. It publishes a test result, it publishes the code coverage, and it runs a SonarQube analysis. However, this library build, in essence, is a NuGet package. And so we need to take the NuGet package and we need to publish it as an artifact on this build. So let's do that. The first thing we're going to do is we're going to copy our NuGet package to an artifact directory. So for that, we have a copy files. And so in our copy files task, first we specify the source folder, which is our source directory. Then we specify the files we want to get. We could be more precise, but I've just included **. I take bin, I take my configuration, and I take my NuGet package. And my destination folder is a build artifact directory in a subfolder NuGet. Now I could add a number of extra flags like clean target folder, but since I've already configured everything to be cleaned every time, in this scenario that won't be necessary. Again, I could force the file to be overwritten, but my supposition is that there won't be any file. However, when copying it, it will be located in a number of subdirectories, and I choose to flatten the file. And so in whatever subdirectory my NuGet package will be located, it will in essence be copied in the root folder of the artifact directory NuGet, and no subdirectories anymore. And then finally I could choose whether or not to preserve the timestamp. But the time difference between the build and the copy is minimal, so I don't really care. But if that's important for you, you can flag this. And then once we have our file copied in our artifact directory, next we need to publish it as an artifact. And for that we have publish artifact, and this one is quite easy. We just specify the path to publish, and so everything which is in our artifactory directory in a subfolder NuGet will be published. I can specify a specific name should that be necessary. For now, I will change that to NuGet, so to be clear that it's NuGet, and I could choose to publish it on this Azure pipeline or as a file share. I choose the Azure pipeline. And then finally, if I want to, I could tar this file for compression, but currently I won't. So let's give it a shot. And then after the build completes, as you can see, one file is found and it's been copied over to our artifacts NuGet directory, and then we have published the artifact to subfolder NuGet. And if we now return to the pipeline itself, we have 2 published artifacts. And if we go into detail, well, we have a subfolder NuGet and we have our code coverage result. And what we're interested in is a NuGet. So now we can use this on our release pipeline. So now let's finalize our web build. We have our shared task group, which does a .NET Restore, a .NET Build, a .NET Test, publishes the unit tests, publishes the code coverages, and runs a SonarQube. What is missing is running a .NET Publish to prepare the whole content to afterwards be put in an artifact so that the release pipeline can use this. So we're going to add a .NET task, and here we're going to configure it as a publish. And in essence, a .NET Publish compiles the .NET project and produces a self-contained publish folder where everything is inside so that it can be used on another machine. That means compiled libraries, dependency files, runtime configuration, output files, etc. Now in general, .NET Publish can be used on multiple types of projects. Here we have a web project, and so we're flagging the publish web projects. And as arguments, again we specify the configuration, and our build configuration is release, and we specify where we want to have our published result as output. And then we also flag the published project, because the output is a folder with a number of files. And so by flagging zip, the output result, instead of being a folder with multiple files, will be a zip file. And then finally, add the projects folder to your publish path, in this case web. That means that everything inside a zip will start with web. Depending on the complexity of your project, you might need or don't need that. If you have just one website and how you later publish it, you might just simply not check this flag. And so this .NET Publish prepares everything and copies everything to our artifacts website directory. And once this is finished, again, as with the library, we need to publish this artifact. And we're going to add the task publish build artifact. And here again, it's the same as before. We specify the location of what we want to publish. It's located in the artifacts directory in the subfolder website. The artifact name we're going to give is website, and we choose to publish it to the Azure DevOps pipeline, but we could also publish it to a shared file. So let's give it a shot. And as you can see, our .NET Publish did all the necessary. It took our DLL and it prepared everything to our Artifactory directory. And then finally, our Publish Artifact website unzipped it and uploaded the zip. And if we now look again at the final result, we have two published artifacts. The first is our code coverage and the second is a zip, which contains everything. And if we have a quick look at the file, we have all specific language, specific files. We have our runtimes. We have everything which is referenced. We have our web exe as well. We have our web library. We have our web config, and we have a complete project. So now we can use this on our release pipeline. So, do we really need this? Well, if you're serious about your product, absolutely. Of course, there are alternatives to Azure DevOps. And everything depends on what exactly you need. The bare minimum, of course, is to build a build pipeline. In there, you will need to do the restore and a build. Afterwards, it depends on how far you want to go and automate. It will make at least sure that between two versions, whatever you thought was working before is still working, or that you might detect some issues quite fast. In the corporate world, of course, this is the bare minimum. So if you guys enjoy this content, please give it a thumbs up, subscribe to this channel and hit the bell sign, or leave a comment down below.